good, my statisticians? This is Professor Sampson from PS I Love Math, back with another statistical banger. We are continuing our study of confidence intervals like 6 video sections later. Now we're going to be comparing our two population means. Remember, sigma is unknown. Sigma is usually unknown. So sigma unknown. But the last two we did independent samples where the samples had nothing to do with each other. This time we're going to be working with dependent samples, which requires us to do something totally different. So before I get into it, and there is a little lecture for this, don't forget to like, comment, and subscribe. So let's get into this video. Okay, so as I said in the intro, we're going to compare two population means when sigma is unknown with dependent samples. Hopefully at the end of the video, you should be able to construct a confidence interval for the difference between two population means using dependent samples. So that's our goal. Why will we need confidence intervals? Like, why will we need to have dependent samples? Well, that's when we're comparing two of the same things, usually on the same person, a pre-test and a post-test, or pairing subjects together for medication. There are many reasons when we want to have dependent samples where it depends on each other. For example, your weight before weight loss and your weight after weight loss. That's a paired sample. So we do it a lot, and they do it a lot in medicine to pair the samples. So when we're doing paired samples, we actually work with the paired difference of these samples because we're looking for the difference between these two samples. So when two dependent samples have paired data, the paired difference for that pair is what we use. And the formula for that paired difference, D for paired difference, is equal to Y minus X. Now that's each individual D, so you might see a little I here, which indicates, okay, the first point, then the second point, then the third point. Another thing to remember is Y, in this case, is the second sample, okay? So Y is the data from the second sample. And X, of course, is the data from the first sample. So from those samples, we get what's known as a paired difference. So we find the difference between those two and we add them up. Now the calculator will be doing this for you, but the mean of paired difference is the following formula. D bar, meaning the mean, right, like X bar, is the sum of all those D's that we got divided by N. So same thing, but again, we'll be figuring that out in our calculator. We won't be doing all this by hand. It's the same formula that we use for what? X bar. Same exact formula. Also, the formula for the sample standard deviation for the paired values is the following formula. Still similar. It's going to be the square root of the sum of D minus D bar. Remember, we did that. This is the same thing with X bar. And the last thing we need to know here, of course, is the error. Standard deviation of the population is unknown as T alpha over 2 times the square root of N. Remember that? Z alpha over 2 times sigma over the square root of N. Same formula. Okay, and this is the error for the paired difference. The confidence interval minus E is less than, now the mean of D is less than D bar plus E. Make sure you check that out and you know that middle, all right? Because that's the mean of the D. It's not just the mean. It's not a mean. It's the mean of the differences. The point estimate for that population mean of the paired differences is mu sub D. That's going to be your good point estimate. So let's get into a couple of problems and see how we work it out. Okay, so here's our first problem. To determine if a new cold medicine works better than the traditional cold medicine, 16 people who had a cold volunteered for a study. The volunteers were matched based on age to create 8 pairs. A double-blind study, we talked about that, was constructed where one of the volunteers in the pair was given the new cold medicine and the other member of the pair was given the traditional medicine. The duration of the cold in days was measured for each person and results are shown in the following table. Construct and interpret a 99% confidence interval for the true mean difference between the duration of the cold for those taking the traditional medicine and those taking the new medicine.
Oh my God!
We know that our confidence interval is 0.99. That means alpha is going to be 1 minus 0.99, which means alpha is going to be 0.01, and then alpha over 2 is going to be 0.005, which is 0.01 divided by 2. And then we know our our N is 16 people. So that means our degrees of freedom is equal to 15, T of 0.005. Let's look that up before we get started. So 15,005 is your area in one tail, 005 area in one tail, and that's 2.947. Keep me honest here, always comment down below if you see a mistake. So we know we actually need D bar, and we also need E. We can write down our formula for E, T alpha over 2 times the standard deviation of that difference over the square root of N. So we don't have anything at all to get our E yet. We have our T alpha over 2, which was 2.947. But we don't have our standard deviation of our difference, and we don't have our D bar. So let's get to our calculator so we can get that. So we need to put our data back in the list.
Whoa, that money clip us now, the new now looks like, whoa, upgrade her diamonds, now her girlfriends are like, whoa, whoa, whoa.
Okay, so all of our information has been put into the calculator. So after we put in L1 and L2, we need the difference between L1 and L2. So you need to go over to L3, go up to L3, and do L2 minus L1. Remember, the difference formula was the second values minus the first value. So second L2 minus L1. Now, if you did something wrong and your numbers aren't even, it'll give you an error because the numbers have to be the same. Remember, they're paired. So here's our L3. So now we don't work with L1 and L2. We're working with the difference, which is L3. So everything we do in the calculator as far as getting answers for this is going to be based on L3. So let's go to stat. We're going to exit out. We're going to go to stat, and we're going to go over to test. Now, what kind of test is this? This is a t-test, and we're looking for intervals. So t-int. Is it 2 samples? No, it's not 2 samples because we're not working with 2 samples. We're only working with the difference, which is 1 line. So this is just a t-interval on line 3. So we go in here. Do we have data? Yes, we have data. So you hit enter on data. What list? We're getting this from list 3. List 3 was where our data was. Never change frequency. And what was our, 0.99. Then you're going to calculate. A couple of things you'll get here. You'll get all your answers, but do not forget to write them down. So the first thing we need for our error is this standard deviation, which comes here. Okay, our standard deviation. Now you have to look at your data to know your rounding rule for your standard deviation. So we have data. We're going to do one more decimal place than is listed in your data. The standard deviation is going to be 0.8. Okay, so that's going to be 0.8. That's the standard deviation of your difference all over the square root of 16. So you need to get your E, 2.947 times 0.8 over the square root of 16. 0.589400, so you can have all 6 of your places. Now you need to write what your D bar is. Again, just like we did for the rest of them, if you skip down and you just write your answer and I don't have a D bar, you're going to get it marked wrong. Yes, it's in your calculator already. So you had it under test. X bar is D bar. The calculator doesn't change letters because you're looking for something different. So X bar is 1.1 or D bar is 1.1. So you got 1.1 minus E is less than mu sub D is less than 1.1 plus E. Yes, you do this whole part. Now we're going to write down our answer, 0.1 to 2.2. So your final answer is 0.1 is less than mu sub D is less than 2.2. You must do this part, and you still have to write down your interval. If you skip this part, I don't know what your D bar was. And now we want to interpret the confidence interval for the difference. Well, the thing about this one, 0 isn't included. We're just going to go ahead and type it up, right? That we are 99% confident that you must say the mean difference, because that's what we're talking about now, between the duration of a cold for people who take the traditional cold medicine and for those who take the new medicine is between 0.1 and 2.2 days. We are 99% confident that the mean difference between the duration of cold for people who take the traditional cold medicine and for those who take the new medicine. So it doesn't matter. Remember in the last one we were saying, well, does the new medicine or the old medicine come first? It doesn't matter. matter. Here we're talking about a difference. The difference between the two doesn't matter whether you say the traditional medicine and those who take the new medicine, or new medicine, those who take traditional medicine, because it's different. It's a difference. We just know that difference between the traditional medicine and those who take the new medicine, that the duration of the cold for those who take the traditional medicine and for those who take the new medicine between 1.1 and 2.2 days. This is Professor Sampson from I Love Math.
Just give it